Good day, students. Today we are going to look at organic chemistry reactions. Okay, we want to focus on the free radical substitution in alkanes. All right. If we are looking at a substitution reaction in organic chemistry, we are saying it's a reaction in which one or more atoms are replaced by another. Okay, so if we look at methane, we have CH4, it's reacting with a halogen molecule, and then we're going to end up with CH3Cl, meaning to say one of the hydrogen atoms has been replaced by a chlorine atom. And as a result, we call that one a substitution reaction. All right, but at ASA level, it is not enough just for us to say substitution reaction. We need to qualify and tell whoever has asked us what type of substitution it is. Because remember, we could also have what we call nucleophilic substitution reaction. So this one, we call it a free radical substitution reaction. And there's a reason as to why we call it a free radical substitution reaction. Okay, so we want to look at why we call this one a free radical substitution reaction. Okay, this reaction is dependent on the availability of UV. So it's a photochemical reaction. Okay, and the role of UV or ultraviolet light is to perform bond fission on chlorine. Okay, so if we start off with our chlorine molecule, okay, there's going to be bond fission here. Okay, and in this case, because these atoms are similar, we're going to experience what we call homolytic fission. Okay, homolytic fission happens in which you have similar atoms whose electronic configuration is exactly the same. So you're going to see that the pair of electrons being shared here, you're going to have one atom is going to end up with one. So I'll use half arrow to represent the movement of one electron. Okay, so homolytic fission will actually give us what we call free radicals. Okay, homolytic fission. Homo means the same. So in this case, ultraviolet radiation will cause homolytic fission to occur here. All right, so we are going to have what we call free radicals of chlorine. Okay, free radicals are species that contain an unpaired electron, and because it's unusual for atoms to have unpaired electrons, they are highly reactive because they are highly unstable. They want to pair up so that they have a low stability. So we are going to have this process happening in chlorine. And for this process, the production of free radical is actually what causes the reaction to start. Okay, this reaction is dependent on the availability of free radicals. Okay, otherwise this reaction will not happen in the dark. Okay, if you want this reaction to happen in the dark, you should have a way of introducing some free radicals there. Okay, for instance, if you want this reaction to happen in the dark, you could actually use what is called lead tetramethyl. Okay, lead tetramethyl can be a source of methyl radicals, and in that case, maybe you can have this reaction starting to happen. Okay, so our process here is divided in the following processes. Okay, we have what we call the initiation. Okay, the initiation is actually what we have written here. Okay, you start off with your chlorine, and then you go on to the formation of your chlorine free radicals. Okay, once you have chlorine free radicals, you can actually have what we can call your step number one. The availability of chlorine free radicals is going to cause the reaction to start to happen. Okay, so let's look at what happens in the next stage, which is normally called the propagation stage. Okay, we now have free radicals available in our reaction, so we want to look at what we call the propagation reaction. So this free radical now, okay, is going to collide with a methyl molecule. Remember, we have a free radical here. It's going to collide with a methane molecule, rather, sorry. And then when that happens, okay, you are going to have HCl plus a methyl radical. Okay, take note of what is happening here. A radical and a molecule, if you form a molecule and a free radical. It's like opposite, okay? Free radical plus a molecule, you form a molecule and a free radical, okay? And this free radical, which we have produced there, can also collide with chlorine, and then you form, okay, CH3Cl plus a chloride radical. So you see what is happening here. We are having our molecules colliding with free radicals, resulting in the production of more free radicals, okay? So in that case, we are propagating the reaction. We are causing the reaction to proceed, okay? As long as this is happening, as long as our molecules are colliding with free radicals, that will propagate the reaction, because that collision is actually causing more free radicals to be availed in the reaction vessel, and that process is called propagation, okay? So the reaction will continue as long as we have free radicals, okay? But it may also so happen that the free radicals may collide amongst themselves, okay? In other words, you can actually have a chloride free radical can collide with another chloride free radical, and that will result in the formation of chlorine. Remember, this is chemistry happening. And in chemometrics, you see, the probability of this reaction happening is random, okay? A free radical can collide with a molecule, or a molecule can collide with a molecule, or a molecule can collide with a free radical, or a free radical will collide with another free radical. And that can actually result in what we call termination, okay? We can also have a methyl radical colliding with another free radical, and that can actually result in the formation of methane, okay? So you can be asked, okay, a question like, when this reaction took place, okay, account for the availability of ethane in the reaction mixture. It says the result of methyl radical colliding with another methyl radical, okay? But for the sake of understanding this reaction, it's divided into three parts, okay? We have stage 1, which is initiation, and then we have stage 2, which is propagation, and then we have stage 3, which is actually termination, okay? So the reaction can only continue to happen as long as you have free radicals, okay? And you can also actually see that in the reaction vessel, we could have other hydrocarbons being formed as a result of a free radical, methyl free radicals being formed, okay? So termination means to end. Once you eliminate all free radicals from this reaction, you can also have the reaction coming to an end, okay? But if you want this reaction to happen, and suppose you don't have solar radiation, this one can be a good source of methyl free radical, okay? It is called lead tetramethyl, okay? This reaction can happen in sunlight, but if you want it to happen in the dark, you can introduce lead tetramethyl, and it can be a source of methyl radicals, okay? So free radical substitution in alkanes is divided into 3 stages: initiation, propagation, and termination. The examinations at ASA level will require you to remember all these 3 stages, okay? Remember, instead of chlorine, they can actually put bromine. Instead of methane, they can put propane, okay? And it's a substitution reaction because we were replacing one of the atoms, in this case hydrogen, with a halogen atom, okay? And we used the sunlight or ultraviolet to perform what we could call homolytic fission. So this is a term that we may also learn here. There is homolytic fission, there is heterolytic fission. In this case, free radicals were generated by homolytic fission, and free radicals are highly reactive because they have an unpaired electron. Having an unpaired electron result in high instability, and the atoms would like to pair up so that they become stable. This was our session today on free radical substitution in alkanes. All right. If you like this video, please show it by indicating like, or you can also subscribe to my YouTube channel, which is Chemistry World, And if you go there, you're going to find a number of videos that I have uploaded. And I hope you're enjoying these videos and you're also sharing them with your friends so that they can also benefit from their revision before they sit for the exams. Thank you, students. Bye-bye for now.